Good evening, everyone. I'm Jonathan Lunine. I'm the David C. Duncan Professor in the Physical Sciences and Director of the Cornell Center for Astrophysics and Planetary Science, and I'm your moderator for this evening's exciting event about the Voyager missions and the Voyager records. And it's my pleasure right now to welcome to the stage Professor Michael Kotlikoff, Provost of Cornell University, who will open tonight's event.
Thanks very much, Jonathan, and good evening, everyone, and welcome. 40 years ago, NASA launched the Voyager 1 and 2 spacecraft to explore the solar system. Today, they remain the only spacecraft to have visited Uranus and Neptune and to have gone beyond into interstellar space. On the side of each Voyager aircraft, rocket ship is something remarkable, even daring, in its ingenuity and optimism. The golden record, a gold-covered copper record that includes greetings, images of life, music, and other sounds, all selected by a committee chaired by our own incomparable Professor Carl Sagan. It is designated to communicate with whatever intelligent life forms may be out there, in case they should encounter this small human-made craft somewhere in the vastness of space, and to give them some idea of life on our pale blue dot, as Professor Sagan called it. Should Voyager fail to make contact soon, all of us who are intrigued by the search for extraterrestrial life can take comfort in the fact that the golden record is expected to endure for at least 1 billion years. Carl Sagan was a professor at Cornell for 30 years. He was both a distinguished scientist and an extraordinary communicator of science to the general public. His passing in 1996 was a tremendous loss, but Cornell is proud to host the enduring Carl Sagan Institute, dedicated to expanding on his vision of a search for life within the solar system and beyond. The Institute is a sponsor of this event tonight, along with the Department of Astronomy, the Cornell Center for Astrophysics and Planetary Science, and the College of Arts and Sciences. Our celebration of the Voyager missions includes a fascinating exhibit at the Cornell University Library's Division of Rare Manuscript Collections, and I hope you'll visit those as well. It features one of the 4 golden record covers that remain on Earth, along with a multimedia display of images and sounds from the record. It also includes the original book by Sir Isaac Newton that was photographed for the golden record. We're grateful to Anne Druyan, Carl Sagan's collaborator and widow, and also one of our panelists this evening, for the loan of the golden record cover. I'm also very pleased to say that Anne will talk with the audience tomorrow after Cornell Cinema's screening of the series finale of Cosmos, featuring the Voyager mission, which she co-wrote, directed, and produced. Here to introduce our panelists properly is Jonathan Lunine, who holds the chair once held by Professor Carl Sagan, the David C. Duncan Professor in the Physical Sciences and Director of the Cornell Center for Astrophysics and Planetary Science. Jonathan?
Thank you, Mike, very much. I'm going to briefly introduce each of the panelists. Then I'm going to tell you one of my stories about Voyager, and then you're going to hear from each of the panelists this evening. We have an extraordinary panel. To my immediate right is Emmy Award-winning writer, producer, and visionary Anne Druyan. To her right is a pioneer of radio astronomy and the inventor of the modern effort to search for extraterrestrial intelligence by radio and other telescopes, Professor Frank Drake. Someone who is exploring Mars literally every day of his life for the last 13 years, Professor Steve Squyres. And to Steve's right, the founding director of the Carl Sagan Institute here at Cornell, an associate professor of astronomy and expert in everything about extrasolar planets, Professor Lisa Kaltenegger. The Voyager missions affected every planetary scientist who is alive today and those who have left us. It had a profound effect on American space exploration and a profound effect on American science in general. Everyone who does planetary science or astronomy has their own story about Voyager. I have several, and I want to tell you one. When I was in college as a junior, I was an astronomy major. I was passionate about astronomy. I had been so since I was a child. But I didn't know what kind of astronomy I was going to do. I had read Carl Sagan's books. I corresponded with him. I'd seen a talk by Frank Drake. All of this spurred me on. But my career has been in solar system exploration, and the moment when I knew that would happen came about in the February of 1979, when I was a junior. And I walked over to the classroom where I was taking stellar astronomy, stellar atmospheres. I picked up my mail at the Student Union on the way. And one of the pieces of mail was a magazine that I subscribed to, Sky and Telescope, mostly for amateur astronomers. Now, bear in mind, this is before internet or anything to do with wireless or any other kind of instant communication. And when I got to the classroom, I sat down, and I had 5 minutes before the class began. I unwrapped the magazine, took it out of its wrapper, and this is what I saw. It was, this is the March 1979 issue of Sky and Telescope. The picture on the front cover is a Voyager far encounter image of Jupiter. This is Voyager 1, taken from about 30 million miles from the giant planet. The close approach was still a couple of weeks away from the time I received the magazine. But everything in this image was remarkable to me and to anyone who saw it, because no human being had ever seen the planet Jupiter to that level of detail. And even though today we've seen many images of Jupiter like this from many missions, no one had seen this kind of detail, and I was absolutely enchanted. And I sat there staring at this image on the front cover of this magazine, and I realized that what I really wanted to do was to participate in the exploration of the solar system by robotic spacecraft, sending instruments, our eyes and ears, electronic eyes and ears, out into the cosmos to actually touch these planets, enter their atmospheres, land on their surfaces. And it was this image that made me realize that that's what I wanted to do. And I'm hardly unique in that regard. Voyager did that to so many different individuals who today are doing solar system exploration or have been inspired by it. So with that in mind, you're going to hear about the experiences of space pioneers and visionaries and people who are working to the future of space exploration. Each of them has 5 minutes to give their own presentation. There will then be a discussion of about 25 or 30 minutes among the panelists, which I will moderate, and we'll then move to questions and answers from you, the audience. There will be microphones set up, allowing you to ask your questions of the panelists. So let me begin with Anne Druyan, who is an Emmy award-winning American writer and Peabody award-winning television producer, specializing in the communication of science. Anne co-wrote the 1980 PBS documentary series Cosmos: A Personal Voyage, hosted by Carl Sagan, who was the David Duncan Professor of Astronomy at Cornell until his death in 1996, and whom Anne married in 1981. Together, they wrote half a dozen books and co-created the motion picture Contact. Anne Druyan is creator, producer, director, and co-writer of the 2014 sequel, Cosmos: A Space-Time Odyssey. And she served, please, go ahead. Fantastic series. And she was the creative director of NASA's Voyager Interstellar Message project, the Golden Records. And in honor of Anne Druyan and Carl Sagan, there are two asteroids named after them, which are in perpetual wedding ring orbits around the sun. Anne?
Thank you so much. Thank you, Mike. Thank you, Jonathan, for all the wonderful things you said. Before I quickly reminisce in 5 minutes about Voyager, I want to say something about this room and Ithaca and Cornell. In the first Cosmos television series, Carl Sagan and Steve Soter and I imagined what the last perfect day on Earth would be like. It was a moment on Earth as the sun transitioned to its red giant phase. And we imagined one last perfect day, a bit like today, actually. Well, in my memory, Carl's last perfect public day, evening, was in this auditorium. It was on the occasion of his 60th birthday, and Cornell University had a 2-day symposium, and then on the final evening, he gave a talk here. In my recollection, I attended every one of his talks for 20 years. This was the greatest one he ever gave. And so it really moves me to be here tonight. Cornell University and Ithaca played a huge role in Cosmos. Both seasons of Cosmos were written here. Frank Drake, who was Carl's co-chair and his partner on directing the Voyager record effort, was here, as was Carl. And our first conceiving of what we would put on Voyager took place in Cayuga Heights. I want to give a shout out to Nick Sagan and ask you to stand. Not only is he a writer and professor, but he's also the spokesperson for the next billion years or so for the children of planet Earth on the Voyager record. I've been told by the public outreach people at JPL that nothing they have ever done, and they've done so much, has ever elicited so much public interest and feeling as the Voyager record. Till this day, they receive inquiries every single day. And I think the reason for this is that Voyager, the mission and the message, was really the essence of Carl Sagan, the idea that our scientific ability and curiosity, our intellect, our cleverness, could be paired seamlessly with the music we make and our art and our dream of unity, of a planet that reflects not just one nation, not just the chauvinism of one people, but all the beauty made on all the continents of Earth. For me, it captures what it was like to be alive in the spring of 1977, and also the fact that my thoughts, my heartbeat in the first flush of a great true love is on that spacecraft and has a future of 1 billion years is so wild and impossible to even wrap your head around. You know, it just says to me how lucky I've been to be a young woman in her 20s and to touch something that will still be moving onward through the galaxy after the last perfect day on this beautiful pale blue dot. Thanks.
Thank you, Anne. Frank Drake is a pioneer of radio astronomy who undertook the first observational efforts to detect communications from extraterrestrial civilizations in 1960 in Project Ozma, and thereby inaugurated the modern search for extraterrestrial intelligence, a search that goes on today. Frank Drake devised what's called the Drake equation, which delineates the various factors involved in the occurrence of extraterrestrial life. And he created, in addition to the Voyager golden records, co-creating those, he created the Arecibo Message, which was a message sent out from the Arecibo radio telescope of an astronomical and biological description of the Earth and our biosphere, which was transmitted in the direction of the M13 globular cluster. So I believe it'll get there in about 20,000 years, something like that. Drake was elected to the National Academy of Sciences in 1972. He is a Cornell alum. He received his bachelor's degree here in 1952, his master's and PhD at Harvard. He was the director of the Arecibo Observatory for Cornell and the Goldwin Smith Professor of Astronomy here. He then went on to become dean at the University of California, Santa Cruz, president of the SETI Institute in Mountain View, California, which he helped to found, and served as the director there of the Carl Sagan Center for the Study of Life in the Universe. Frank.
Thank you, Jonathan. That was very nice of you, and it always warms my heart to know that you are one of my products in some sort of way. That may be one of the best things I ever did. I'm very touched to be here tonight. When I arrived here in Ithaca yesterday, it occurred to me that the first time I stepped foot on the Cornell campus was 70 years ago, just about to the day. And it's been a wonderful 70 years, and much of it can be traced to what started 70 years ago. I learned at Cornell that this was a place where innovation was encouraged and honored, and to be conservative and withdrawn was not what we wanted people to be who graduated from this place. And so in the years to come, after I left here and as a graduate in 1952, actually, I served some time in the Navy. I went to graduate school. I went to the Jet Propulsion Laboratory. But I found that the real place to be was here in Ithaca. And so I came back and had a very long, wonderful time here. And one of the great events in that time, which involved making the Arecibo Observatory one of the world's best, among other things, was certainly the work that was done on the Voyager record. That came about, as has already been suggested, by Carl getting the idea of putting a message on a spacecraft. This was the second one. This was not the first. The first was the two Pioneer spacecraft that preceded the Voyager record. And Carl had come to Cornell for the very good reason that it was a place for innovators, and Carl was certainly a very great innovator and speculator and builder of great new ideas. So it was a real pleasure to be here and work with him, and the day came when NASA asked him to put a message on a spacecraft, the first one, which was the two Pioneers. And I had been an engineering student, and I kind of knew what was possible with a spacecraft and what you could construct and what would survive and do a good job as something that was going to last a very long time in space. So Carl came to me and said, "What do you think we should put on the spacecraft?" And on that occasion, I told him, we'll put a plaque, a metal plaque, with artwork on it depicting the life on Earth as best we can on one single plaque. Now, Carl took that and improved on it, added a sketch of the solar system, and went to NASA and sold it. And that was one of his good traits and abilities, too. He could sell things very well to NASA officials. And that's very important in the world of space science. And so the Pioneer plaque was built and was launched. It's far out in space now on two spacecraft, not as far as the Voyagers. The Voyagers overtook it and passed it a few years ago, those plaques. Well, a few years went by, and again, another spacecraft was being ready to go out of the solar system. The Pioneer plaques had been the first to do so. And so we got together again, and Carl said, "Okay, what about this time?" And I said, "Well, this time we had more time, we had more weight we could put on the spacecraft. We should do something much more significant." And what that was something that would be made of metal, so that it would last for the billions of years it would be in space, and something that could carry a lot of information. Carl was particularly partial to putting some music on the spacecraft, on the thing we sent, because he felt that was a great measure of the quality of our society and of our intelligence. And so the idea came about to make a phonograph record and put it on the Voyager. Sorry, I'm getting the two confused. And Carl went to NASA as before and sold them on the idea. And NASA said, "Go ahead. This time you have more time." Well, the first time we'd had about a week. This time they gave us over a month. But we had to plan 2 hours of material to put on a phonograph record. Carl wisely divided up the work. He signed the music here and the voices of Earth there, Annie, and so it went. And I had the idea of putting a lot of pictures, television quality on the record, and in that way, in a very sociable, if you will, and supportable way, we talked each other into what we should put on the spacecraft. And then we went to work. And that turned out to be one of the most beautiful events in my life I ever had. We gathered together 4 or 5 Cornell staff to help pick out photographs to put on the spacecraft. When I first did the analysis of how much information we could put on the spacecraft, I thought we could put at most 12 pictures on it. But once we got into it and we talked to the people who make phonographs and knew how to condense information, it turned out there was room for over 100. And suddenly that was not only wonderful, but very challenging. We only had a few weeks to find 100 photographs that had to be an accurate and inspiring picture of life on Earth and our creatures, the human beings. Our little group worked as a wonderful team, and it was good to see there were no egos present. We all had the sense that we were doing something very important. We were creating a record of the existence of our planet and our civilization that would last longer than the Earth itself, and might never be found, but if it did, it would be the only thing in the universe that would record memories of our whole history and our civilization. And this both weighed heavily on us, but inspired us. And everyone worked well and joined together in making decisions on which pictures should be on it. And in the end, we came up, I think, with a very good set of pictures, which you were watching before we started this session. In the end, NASA was happy with what we did. We saw the record completed, essentially untouched, and launched into space in a beautiful blast of rocket power at Cape Canaveral back in 1977. And all of us had the sense that we had done something very important. And I think my last comment is it amazes me that 70 years later I'm sitting on the stage of Bailey Hall, which I'd never been to before. And what an amazing world this is.
Thank you, Frank and Ann, for your roles in leaving something that will be a permanent memorial of human accomplishment. So we move on now to exploration on the surface of the red planet. Stephen Squyres is the James Weeks Professor of Physical Sciences here at Cornell. He's a Cornell alum. He got his bachelor's in '78, his PhD in 1981, worked with Joe Vaverka and Carl Sagan. Steve was the inventor of the idea of a compact roving payload on Mars called Athena, which he was able to implement as the principal investigator of the Mars Exploration Rovers. Those are Spirit and Opportunity. And of those two, Opportunity is still going strong after 13 years roaming the surface of Mars, an incredible record. Professor Squyres has participated in... Steve has participated in many other planetary spaceflight missions. I won't bore you with the list, it's very long. He's the recipient of the 2004 Carl Sagan Memorial Award of the American Astronautical Society and the 2009 Carl Sagan Medal for Excellence in Communication in Planetary Science of the Division for Planetary Science, of many other awards. But I don't want to take up his time because he's going to tell you all sorts of fascinating things about Voyager. Steve.
I'd like to bring the lights down just a little bit so we can see the screen. So I'm going to tell you the story of one of the Voyager mission's first and most important scientific discoveries. When Voyager 1 flew by Jupiter in March of 1979, I was a first-year graduate student here at Cornell, working with Professors Joe Vaverka and Carl Sagan. I was 23 years old. And I was just so fortunate to be able to be at the Jet Propulsion Laboratory as the spacecraft flew through the Jupiter system. Now, the Voyager encounter with Jupiter, the heart of it lasted about 48 hours. That was how long it took the spacecraft from the first moment that it crossed the orbit of Callisto, the outermost of the big moons, flew by Jupiter, and then crossed the Callisto orbit again, 48 hours later. None of us slept for 48 hours. We were awake the whole time. Fresh images were coming down from the spacecraft about once every 45 seconds, and it was phenomenal. The most dangerous part of the encounter was the point of closest approach to Jupiter. No one had ever flown that close to Jupiter before. Nobody knew how dangerous the charged particle environment was. Charged particles trapped in the Jovian magnetosphere had the potential to kill the electronics on the spacecraft. It was uncertain. So we got through the first 24 hours of the encounter. We got to closest approach. The spacecraft was still alive. And so after we got by closest approach was when we broke out the champagne. This was just at the moment when we were going to fly by Io, the innermost moon of Jupiter. And Io was an incredible mystery. It's very, very strange, and nobody knew what was going on there. It was a strange place. So we'd all been awake for 24 hours. We're drinking champagne, and some of the most significant significant images of the missions were coming down during that. Our powers of observation were not at their peak. And let's just say we missed a few things. Finished the flyby. We all went home to sleep it off. And fortunately, over the weekend, some of the engineers who had not been drinking champagne were hard at work. Check this out. This image was taken for navigation purposes. It's an image of the moon Io. It was overexposed so you could see stars in the background and figure out where the spacecraft was. And the engineer whose job it was to analyze this image was named Linda Morabito. There she is, rocking this awesome 70s haircut. I shouldn't talk. You should have seen what I looked like back then. And Linda looked at this image of Io and noticed this. There was some thing in the picture. And her first thought was that it looked like it was another moon. She checked, and there was no other moon that could have been there, so it wasn't that. And so she, very correctly, very conscientiously passed this along to the imaging science team. Okay. Next morning comes. We're straggling back in. I get into the imaging science area, and the other grad students are milling around. There's gossip in the air. Something's going on. All the important people on the science team, not me, all the important people are locked in this one room talking. Something was found over the weekend. It's big, it's mysterious. We graduate students don't get to find out. However, down the hall, in the room where we had the image processing computers, one of my advisors, Joe Vaverka, was at one of the image processing machines. I couldn't see him. But I hear an exclamation from down the hall. And some of you know Joe. You can imagine what it might have been like. We're in polite company, so I will not repeat the exact words that he shouted. It was along the lines of divine excrement. I rush down the hall, and I look at the screen, and there's this. And here's this image of Io, and then perched on the limb, looking like a giant tarantula, is this thing. It was a volcano that was erupting as we flew by. These pictures were coming down 2 days earlier, and we didn't see them because of the champagne and the sleeplessness. We sheepishly went back through the images and finally realized that there had been 7 volcanoes popping off, spewing sulfur compounds into space 300 kilometers as we were flying by. Io was shown by Voyager to be the most volcanically active body in the solar system. This was just the first among many utterly groundbreaking discoveries made by the Voyager mission. It is exemplary of what a class act the Voyager project was, through and through, that the paper that was published in Science reporting on the discovery of volcanoes on Io, the lead author was Linda Morabito. There are many great missions of planetary exploration that have taken place. There are good ones that are taking place now. But for my money, the greatest in history is Voyager. You only get to do something for the first time once. And Voyager gave us our first good look at the Jupiter system, the Saturn system, the Uranus system, in the Neptune system. We will not, in my opinion, top Voyager until we send a spacecraft to another star. Thank you.
And to think that it nearly didn't happen because there were some scientists who absolutely knew that the moons of the outer solar system would be dead, gray, covered in dust, not worth looking at all. Thank goodness their views didn't prevail. So Steve mentioned going to planets around other stars, and our extreme right hand, in terms of position, not politics, panelist tonight is a leader in that effort and will lead us here at Cornell in this extraordinary area of understanding the habitability of planets around other stars. Lisa Kaltenegger is Associate Professor of Astronomy, and she's the founding director of the Carl Sagan Institute at Cornell University, which is a multidisciplinary, multi-department, multi-college effort to understand planets in our own solar system and planets around other stars, and whether they have life and are habitable, and all the exciting questions we want to know the answers to. Her own research focuses on rocky planets and super-Earth atmospheres in the habitable zone around other stars, as well as the spectral fingerprint of exoplanets that can be detected with the next generation of telescopes. Lisa Kaltenegger was named one of America's Young Innovators in 2007 by Smithsonian Magazine, was selected as one of the European Commission's role models for women in science and research, and recently received the Heinz Meyer Leibniz Prize for Physics of Germany in 2012, among a number of other awards. Lisa Kaltenegger.
Thank you very, very much. And man, I should have known not to go after Steve Squyres. But in this one thing, I might actually be able to say, in my field at least, even though I love Voyager, and I'll tell you why it means so much to me. I actually don't agree with you in meaning that we need to send a spacecraft somewhere else to another star. We actually have the tools in hand for the first time in human history to actually spot signs of life on other planets if they exist without having to go there. And that's what I work on, because distances are vast. And so if you have the solar system and you shrink it in your mind to the size of a cookie, that's where we kind of can go. We only really made it, well, we kind of made it out of the cookie. That's, for me, one of the amazing things about Voyager 1. The only human-touched satellite object ever to leave the gravitational bounds of our own solar system. I think that's an amazing humankind's achievement. But we're living at the time where we've developed the technology that by looking at light, catching it in our telescope on the ground or in space, we can actually start to analyze what's in the air of other worlds. And we are also the generation that actually is finding these other worlds for the very first time. And in this Voyager event, I am incredibly grateful to be here at Cornell, because honestly, to be able to share the stage with everybody up here, I'm from Austria. I studied on a very small Austrian university, and I know these people out from textbooks. So, and I was thinking about bringing my textbooks and have them all sign it, but I figured that was a bit too nerdy. But one of the things that motivated me to do what I do, find other Earths, trying to figure out what's a glimpse into our potential future, and of course, the incredible curiosity of how we actually fit into this big universe and whether we're alone, is the image that Voyager took of our own planet. This pale blue dot, if you've seen it, it's just basically the vastness of space and this tiny, tiny pale blue dot. And the story that Carl Sagan, with Anne's help, wrote about this pale blue dot is still mesmerizing, what it means, how fragile our world is. But it actually shows our world as this pale blue dot suspended in the vastness of space. And exactly that is what we are now doing for other worlds. We're finding these other dots. We can't tell you yet if they're blue, because we're waiting for the James Webb Space Telescope that's going to launch early 2019 to collect enough light to tell us whether or not one of these worlds, if they're close by, we might get enough light, might be like ours. But what we can tell you already is that 1 out of 5 stars, if you look up in the sky and say 1, 2, 3, 4, 5, one of these 5 alien suns that you see in the sky has a planet that could potentially be like ours. And my story isn't as great as the one that Steve had with the champagne, because we didn't have champagne. But, and I think we should remedy this, because, now that I know that that's the way to go, I'm going to do planetary science, not astrophysics. We had in 2013 the first detection, or we talked about it in 2013. In 2012, at a meeting somewhere, you're standing next to this poster, you have this terrible cup of coffee in your hand that you really shouldn't drink, but you're at a big science meeting, the coffee is terrible, you've drank way too much, but you're there. One of the scientists, the PI of the Kepler Mission, it's NASA's mission that stared at all these other stars, 150,000 in the sky, and found these other potential Earth-like worlds, came up and he said, Lisa, we found 2 planets that we think could be Earth, and we think they could be in the habitable zone of their stars, right? So imagine me, terrible coffee, chin on the ground. And he was like, I would like you to look at it, right? And I was like, this is amazing, right? And he was like, but you're not allowed to tell anyone. So I'm like bouncing up and down, that coffee, great news, and I'm not allowed to tell anyone. I did make an exception for my husband, but I swore him to secrecy. And so it actually turned out that in 2012, we found, or the Kepler mission, so I just helped on the theory side, I didn't find anything. I just said, okay, at this distance from the star, it's not too hot and not too cold, so these planets could be Earth's analogs. But we had a year where we tested the signals because we didn't have pictures. We just had this tiny dimming of light of the star that told us there was a planet blocking our view of the star. And every email you get, and now imagine a year, and imagine about 5 emails a day that could tell you the signal is wrong. So I was just like sitting in front of my computer for a year, and I was like, please, 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 no, please, 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 right? And it turned out that in the end, we were really lucky that these 2 signals were not errors on a detector and were nothing else. So I think I'd take Steve's version 2 days, great picture, and a paper, instead of 1 nerve-wracking year trying to hope that none of these emails were the wrong ones. However, you have a beautiful moon with volcanoes, but the year and the nerve-wracking got you 2 potential other worlds. And that's the time we live in. And when Annie was still incredibly graceful and kind to tell me, when I told her about this institute that we were envisioning here, I called it the Institute for Pale Blue Dots. And then Annie came down and she said, what are you guys going to do? And then she said, well, you know what, Lisa, if Carl were alive, that's what he'd want to do. Again, chin on the floor and oh my God, right? Do not mess up this institute now. But with that, I think Voyager has given us this amazing view of our solar system. And with that motivation and inspiration, we can now look at the next horizon, other solar system, and hopefully other worlds like ours. Thank you.
Many of us were so glad we were able to woo you away from that little country of Austria that you mentioned to be a faculty member here. So I want to ask each of you, and I'm going to challenge you to answer this question in 2 or 3 minutes apiece. 2 minutes apiece. Anne talked about the last perfect day. And here we are with global warming in full force, monster hurricanes, disasters, overpopulation, starvation, the threat of nuclear war again, amazingly. Who would have thought this would happen again? Why should we be doing this? Steve said that Voyager, there'll be nothing else like Voyager. So if there was nothing else like Voyager, maybe that's all we need to do. Why do we need to keep sending probes out to the solar system? Why do we need to build new and larger telescopes to get details about these habitable planets? Why should we be doing this in the midst of all of our current troubles? I'll let you self-select who wants to go first. Steve.
All right, personal opinion here. I really feel very strongly that in a society that is wealthy enough to do a pretty good job, not a perfect job, but a pretty good job of taking care of the basic needs of the citizens, that we have a responsibility to spend some of our resources on things that, for lack of a better phrase, enrich the human spirit. And I think we should be spending money on basic research that's not going to pay off maybe for centuries, maybe ever. We should be spending research on exploration. We should be spending money on the arts, lots of it, okay? All of these things we should be doing. And you know, these missions that we're doing, they don't fill in the potholes, they don't put roofs on the schools, they don't put textbooks in the libraries, they put knowledge in the textbooks. And you know, the Mars rover mission, we've spent $1 billion. $1 billion driving Spirit and Opportunity around on Mars. Your taxpayer dollars, thank you very much. But I take that number very seriously. I take it very seriously indeed, and I look at what has happened, and I sleep okay at night. And I got to tell you, it's more than just the science. You know, I grew up in the 60s and 70s watching Mercury, Gemini, and Apollo, and dreaming of sending spaceships to Mars someday. And now I get to. And there's a generation that has grown up watching Voyager. That was my generation. Watching the Mars rovers, watching the fantastic missions that are yet to come, and they're going to be inspired to great things as well. So I feel okay about it.
All right. Who wants to take, go ahead. I forgot to tell you we're not rationing applause tonight, so feel free, burst out. Who wants to try this next? Anyone else want to comment on this?
I could try.
Lisa, yes.
So for me, it's, I get this question a lot because we're talking about the search for other worlds. We're talking about, are we alone in the universe? And I think, for me personally, this curiosity has always helped humankind, right? Every step, every next exploration we take leads us to something we can't even imagine. Leads us to things we discover that then trickle down to our daily lives as well. But it's not why we do this. We're not doing this to make your iPhone better. We're doing this and then we invent an iPhone, right? Something like that. But even if you don't care how you're connected to the universe, and for me, in times like these, as Jonathan was saying, it actually becomes more and more important to sometimes just look up at the stars and just forget all the crap around and just see these other worlds and see this fascinating journey that is just in front of us because we don't know yet, and it's just there and we can figure it out. But even if you don't care about all this and if you don't want to do exploration, what we have is our own beautiful, amazing pale blue dot. And what we could use is a little bit of help to understand it better. And so if you could find Earths out there, other Earths, like say 50, 100, those would actually give you data points of how an Earth-like planet works and how it develops, what it does in the future. It gives you a glimpse in a potential future. And it's not a 1-1 match, but if you were to find, let's say, 50 other Earths that are older than us, and all of them, this is now just an example that I'm making up, had a lot of SO2, sulfur dioxide, in the atmosphere. It's something we can't breathe. That doesn't mean that's going to happen to the Earth. However, it means it's going to be really smart to develop a technology to filter SO2 out of our air just in case it happens to all Earths when they get older. So the practical aspect, even if you don't care about exploration and basic research, is the more we understand about how an Earth-like planet works, the better we can figure out how to safeguard our own planet.
Thank you. Yeah. Anyone else want to take a crack at this?
I'll take a crack at it.
Yes.
It's a rare occasion for human self-esteem. 50,000 years ago, blink of cosmic time, blink of an eye, we were beings who were mystified by fire. And now we're beings who can not only reconstruct the history of the universe, not only send our spacecraft beyond our solar system into the sea of interstellar space, but also begin to do as Lisa, Steve, and Frank have done and are doing to get a sense of the universe. We are born in a kind of cosmic quarantine, and it takes a really long time to figure out how to escape the planet's gravity and to begin to reconstruct our past. You know, I always think we're like the baby left in the basket on the doorstep with no note. And what have we been able to do? We've been able to create an error-correcting mechanism called science that makes it possible for us to do things that our ancestors would rightfully have thought of as mythic magic. So why do we send spacecraft to the planets and to the moons and beyond? Why do we look to find Earth-like planets around other stars? Because that's one of the few things that we're doing lately that we can rightfully feel so proud of. Everybody on Earth, to be human, is to want to know if we're alone in the galaxy and the universe. You have to be made of wood, not to feel something, to understand a little bit about nature, the little we do understand so far. So if we stop doing these things, then we can declare ourselves officially dead, because we're not doing a very good job of taking care of our pale blue dot, or even ensuring that our children and our grandchildren will have a livable world. So I say for the, what did you say tonight? It's 100,000th of our federal budget. That's how much we spend on doing these things that give us such a sense of pride and wonder. Maybe when the balance of how much we invest in our future and in science changes, shifts, we'll know that we're home free.
You want to add something, Frank?
Well, going forth in this group is a hard thing to do because they've all said the right thing. And anybody who has been associated with the space program knows that it's presented with constant, very big challenges. Barriers to crossing space, barriers to surviving, either as a living thing or as a machine in some cases. And this creates challenges to the intellect and to one's technical abilities and the ability to build things. And all of this, when we conquer it and achieve a good result, builds confidence and pride and motivation to do more good things for our culture and our people. And so it's a way of building space research and everything associated with it is a way of building confidence and enthusiasm for the future, and we need that. And that's what you've heard before, and I second every sentence of all three of our people. I would add just one thing that in my mind, and I look far into the future sometimes in my imagination, I see that if we have sufficiently powerful ways to go into space and to observe things, we might, and we will, I think, I will use the word will, find other civilizations in space, and we'll find them with the ability to learn what they are like, how they live, what things they have created, and what good things they have found to make their own situations better. And we will learn from that. I think we will learn good things. It does take space capabilities beyond what we have now, but the possibilities are there. There's been many people who have pointed out that our sun, and this is far out thinking, but it's a true thing, our sun can be used as a lens to build the largest, in effect, telescope ever conceived that will greatly outdo any telescope we can build out of steel and glass here on Earth. And that with such a telescope, we could actually observe what is going on in other worlds, many hundreds of light years away even. And from that would come not only spectacularly interesting information about what evolution can lead to, what forms of intelligent life exist, what do they become when they are millions of years ahead of us in their evolution, but it will even give us some practical ideas as to what works and what doesn't. Does colonizing space work, or does it turn out to be a losing proposition, too dangerous and too costly? What do you do about population explosion? What do you do about an overheating planet? Do you build floating cities on the oceans? We have some experiments of that in places like Hong Kong already. But is that a way of coping with a growing population and maintaining a good quality of life for people? These are things that are within our reach in accordance with what we know of physics and astronomy. What isn't in our hands yet is the equipment, the instruments that can exploit these capabilities. The ability is there, built into the laws of science and of nature. We just haven't used them yet. And I think we should continue to take steps, as we have already in our space program, to reach the capability of studying those other worlds in space. I think this is a reality, not just a dream.
Thank you. So while I'm asking the next question, I believe whoever is in charge of the microphones is going to move them to a red X on the floor. And then those of you who would like to ask questions, start lining up. And if nobody lines up, I'll ask another question. So the way you can avoid that is by lining up with your own questions. So let me ask one more, and those are wonderful answers, but you didn't hold to your 2 minutes. So now you get 90 seconds apiece, okay? And actually, this time I'll cut you off. What, for each of you, is the next step in space exploration? For planetary exploration, for extrasolar planets, whatever you like, 90 seconds, what is the next step, in your opinion? We'll start with Lisa.
Collecting enough light from a small or potentially habitable planet to figure out if there's life.
Great. Anne.
Well, the next step. Well, I would like to plunge into those frozen oceans, go plunge through the ice on Enceladus or Europa, and sample what's swimming there.
Thank you, because so would I.
Yeah.
Thank you very much. Frank.
I'm going to give two responses real quick. First, let's get to Europa and Enceladus and see if there's living things there. That's very important. It will show there, if there are, it shows there has been a second genesis, and if there were two genesis, there's lots more that have occurred throughout the galaxy. The other thing, which I think we need to do, is get a spacecraft to the gravitational focal point of the sun That's a real point. We know it. It's in the literature, in the scientific literature. It's 500 astronomical units from the Earth. But when you get there, you can use your sun as this gigantic lens and actually see other planets and the continents and whatever else is there. And we need to do that.
Excellent. Steve?
All right, well, Frank and Ann already mentioned submarines on Europa and Enceladus, so I'll pass that one by. And I will say bring back carefully chosen samples from the surface of Mars, taken apart molecule by molecule, and find out if life ever arose on the red planet.
The amazing thing is we can do all these things,
Yeah.
right? Absolutely.
Right.
Thank you. All right, so here's how the Q&A is going to go. We have 3 microphones. I'm going to take a question from each station in succession. If you have a particular panelist you'd like to ask your question to, please identify. Otherwise, I'll pitch the question over to whoever I think ought to answer it first. These are questions, not colloquies, so please don't be insulted if I cut you off after your first question. Want to make sure that we have the chance for the maximum number of people here in the audience to ask their questions. And so you are first on my left.
Hello, I just wanted to say first, thank you so much for coming and delivering this. I teared up multiple times, and I'm not embarrassed. And I saw the golden records at the library today, and I'm going to go in tomorrow, and I'm going to go in Saturday, because it was really wonderful. So for Ann, Druyan, and for the entire panel, if you were doing this project again today, what images and what audio that have happened in the past 40 years would you want to include?
What a great question, and thank you so much for your enthusiasm. Well, you know, there was one picture, a great picture, that was not included on the Voyager record. And it was the picture of a man and a woman who were frontally naked. She was about 4 or 5 months pregnant. And it was vetoed by NASA. And that's how much we hate ourselves. We couldn't bear the thought that we would be standing naked before the universe. So while it was contemporary with the actual making of the record, that's the one component of the record that I have regretted all these 40 years. Because I believe that if we could have sent that picture, it would have said something so hopeful about our mental health as a species. Things that have happened since the record, you know, I'm sorry I didn't put Bob Marley's No Woman, No Cry on the record. I've listened to it 10,000 times since then, and I've always felt a pang each time that we didn't include that.
Thank you. Is there someone up at the top?
Yes.
Go ahead.
Oh, that's me.
Yes.
Cool. Hi. Yeah, sure. So this may be a slightly radical question, but given the altruistic nature, at least in my mind, of space exploration, how do you think in going forward in the next decades should we balance a capitalist economy and its goals and aspirations and the rapid things that are happening? I won't go into it. With the continued goal of space exploration, because we're seeing companies like Deep Space Industries and SpaceX capitalizing on the idea of this altruistic goal, but I have concerns, and I was wondering if you have concerns as well.
Okay, private industry in space. Who wants to take that? Steve?
Sure.
Okay.
I'm a big fan, actually. I'm a big fan of private investment in space exploration. What's happened is, as has happened at other times in history, government opens the frontier, kicks the door open, but then it can become a much more widespread thing. I'm a big fan of SpaceX. I'm a big fan of Blue Origin. I think these are companies that are going to do things that do them in faster, more innovative ways than NASA might. I think you're still going to see that the core of the science is going to be still federally funded. I think that's the way we're going to see things. But when it comes to sending humans out there, maybe even colonizing places, certainly going for space resources and that kind of thing, I think there's a hugely important role to be played by private enterprise, and I want to see it happen.
Okay, anyone else want to take that too? No? Okay, over on the my right.
Hi, where and how do you think humanity will first detect life, and intelligent or otherwise? And I kind of want to
Lisa, let's start with Lisa.
I think it's going to be a really, really exciting race, and I love that it is, with the exploration of the solar system. Because as you're saying, if we plunge through the ice of Europa, and if we unlucky in how much identifiable life we can find, right? So we'll have the telescope, the James Webb Telescope, early 2019. But if life doesn't produce unique signatures, that would be oxygen with reducing gas, that we can't explain any other way, if it produces mostly CO2 or methane, then I won't have a unique identifier that there's life on another planet. And then solar system actually has a chance. Even so, Steve could know something right now that I don't know about Mars.
I can't tell you about it.
I love that it's a race because in the solar system, we can look in detail. For extrasolar planets, we can find planets that are like ours. In our solar system, it doesn't exist. So it's a completely different component of the same endeavor, but for an exoplanet, cookie, and then the next star is 2 football fields away. That means I can't look in details, but I can look at the gases life produce and figure out if it's similar to Earth. I love the race. I happen to go for the Earth-like planets because I want to find many worlds with life, and I have thousands to pick from what I love. But equal opportunity, I think the 8 in our own solar system plus the moons, to give you a couple more, are actually nice places too.
Thank you. All right, over here.
Hi. I'd like to ask about your thoughts about the very compelling WOW signal that was intercepted by SETI.
Oh, Frank.
Yes.
Wow, that's a tough question. For those of you who don't know what he's referring to, there was a famous event that occurred at the Ohio State University, 20 years ago now, where they picked up a signal which had exactly the characteristics of an intelligence signal. They didn't realize it till days later. And so they had this candidate signal, and was it really extraterrestrial? There wasn't much data about the signal except that it was there and appeared to increase in strength and decrease in strength as it should have if it was at great distances. But there's some of the data we wish it had, such as the Doppler effect in the signal, which wasn't there. And in the history of SETI, we've seen many signals similar to that, where when we went back immediately and looked, we could determine that it actually was a signal coming from something on Earth or from an airplane or a spacecraft. And in this case, well, in all cases, what you do is go back and take a second look, see if it's still there. In the case of the WOW signal, because it created a lot of attention, many different radio observatories have over the years looked at the spot in the sky from which they think that signal came, and even that is not well established. And they've looked for literally hundreds of hours, and no signal has ever been seen again. And so the conclusion of all the radio astronomers is that this was just a case of what we call radio frequency interference. It was a transmission from one of our own radio transmitters that happened to mimic an extraterrestrial signal. Now, that doesn't mean it really wasn't, for sure, an extraterrestrial signal. We have to be honest as scientists. That's not conclusive. We just don't have enough data about that signal to really conclusively say, no, it was from Earth. But it's very likely it was from Earth and not an extraterrestrial signal. And so we're left with this slight uncertainty, but there's no professional radio astronomer that thinks the WOW signal is an extraterrestrial signal.
As Carl Sagan said, extraordinary claims do require extraordinary evidence, especially in this case. Yes.
Yeah, Carl said it right.
Okay, thank you very much. On my right.
Hi, I just want to start out and say thank you so much for being here and also just for all of your lifelong contributions to science and society. It's truly inspiring. My question for all of you, I guess, is for the golden record, when it lands, if it lands wherever it lands, how will the record be played, and do you expect it to sound any different on a planet that may have different atmospheric contents? Will it sound different to whoever's listening to it?
Frank?
We took care of that. The record is in a very nice box which protects it from damage. And on the cover of the record, which you can see in the exhibit, you will see that there are diagrams which tell you how to extract the pictures and musical sounds from the record. And in fact, we actually sent more than a record. We sent the stylus from the record players of that day, those days. So we sent them the pickup, as it was called, and we sent the instructions. The only thing we didn't send them was the audio system. They have to be smart enough to build that. But we sent them the thing that will extract the information in a playable form from the record. And in addition, there are diagrams on the cover of the record which tell you how fast to spin the records. You see, that matters. There's no special rate of rotation for records. It's arbitrary. And so we told them, it was 16 1/3 revolutions per minute. And it tells them to play the record from inside out, the way our records are played, because you can turn it back, you can turn it the wrong way around and play it outside in, and you get crazy things. And we didn't want them to get crazy things. And then we gave them examples of how to decode the pictures, which were actually coded just in the same form as our television pictures, where lines are drawn on the television screen. We told them just how those lines should be drawn. And then we put, in fact, a copy of the first picture that's on the record, which is simply a circle in a rectangle. The Japanese like that. It looks like a Japanese flag, but that's not what it is. It was put there because it allows them to determine if they are decoding the right things right, because the first thing they should find is identical to what's on the cover of the record. But more than that, there's also the puzzle for them as to what the so-called aspect ratio of the record is. What's the ratio of width to height? And that is explained, again, by the same picture of a circle, because you have the right width to height ratio if, when you put the data down, you end up seeing a circle, a duplicate of what's on the cover.
Wow. So if they play it backwards, do they hear Paul McCartney's? It's a very old joke. Thank you very much. Yes, over here.
Hello, everyone. I was wondering, obviously because water is a huge aspect of what we consider a planet to have life or not. And I guess the biggest thing here is how have we modified our search for extraterrestrial life, given that there's a big possibility that some civilization may be entirely underwater. Even though radio waves don't really travel through water very well, how have we sort of modified our search because of that?
I'm going to start with Lisa on that, and then Frank for the second half.
So I'm not going to talk to radio. Frank is going to tell you about that. But what we worry most about is if it's cold enough that the ice actually freezes, because that could trap gases that any kind of life form that's in the water, that could trap it under this ice layer. As long as there's no ice layer, gases that fish breathe or whatever you want can actually come to the air of that planet. And the only signal I have from a faraway planet is the light that actually passes through the air of the planet before it gets to my telescope. And light, when you go outside, it gets warm, is energy. So what light does is when it hits a molecule in the air of a planet, it actually makes it rotate and swing if it's just the right frequency or color of light. And that's what's missing in my telescope light, so I know what the air of another planet is made out of. And so I really don't know what the life forms are and where they are. I just don't know that they breathe. And so for me, they can breathe underwater as long as there is no layer that actually blocks the gas from coming out. So I'm fine with water civilizations. Question is how I'm ever going to tell if I'm looking at a dolphin colony that breathes or something else. That's the next step. When we have signals of life, I'll worry about the next one.
So Frank, radio astronomy at the bottom of the ocean.
Radio astronomy on the bottom of the ocean?
Yeah, that was your second question, right? What would happen if you had life forms that actually were marine and existed at the bottom of the ocean? Is there any hope that radio astronomy is at all relevant? Is that right? Radio communication.
Doing radio astronomy from the bottom of the ocean is possible, but it's really stupid.
Unless you're a dolphin.
There's your answer.
That's the answer.
So I think the bottom line is, if we're talking about a planet that is completely water covered, where these intelligent, self-aware beings are at the bottom of an ocean, we probably don't have much chance of communicating with them. Is that fair enough?
You can communicate, yes, but the radio waves don't carry very far. That's the problem. Okay. The water absorbs the waves, so a radio signal that might go 100 miles in air might go 100 feet in the ocean. It depends on the frequency. It depends on the amount of salinity in the water and other minerals, because that affects how fast the radio waves are absorbed in the water.
I actually just
Okay,
think
now we're going to play.
comment.
Actually, I have a, okay,
Sorry.
30 seconds because we're running out of
Quick
time.
comment. I think you just made Frank actually modify his Drake equation. It's going to have now a new term, how far underwater they are.
That's true. Right, exactly. Good. Okay, thank you. Now we're going to play speed question and answer. So the way we're going to play this is the first three people at each microphone can stay. Anyone behind them, I'm sorry, you'll have to sit down because there won't be time for questions. And you have 15 seconds to ask your questions, and you have 1 minute to answer them.
All right.
And so we will start on the right. And I apologize to those people for whom there isn't time to ask questions. You might be able to sneak in a question at the end while the panelists are still on the stage. Go ahead.
All right. So do you think it's necessary for we to consider that life might exist in form other than carbon form? Because given that we can keep a rover that is now carbon-based on Mars to survive for decades, so do we need to look into like other, in our consideration, inhabitable place in other system or planets?
Okay, silicon-based life. Who wants to take that in 1 minute? Lisa.
When you look at the universe, you see carbon everywhere, water, and oxygen. So the question is more, even on the Earth, life could actually use something else. However, it doesn't. It's very good at using the abundant stuff. So we'll keep our eye open for things that don't make sense, but because we don't have a sample of life that's not carbon-based, we don't know how we would detect it. But as scientists, we keep our eyes open for weird stuff. Absolutely.
Great answer. Thank you. Over here.
Hi. Thank you all for being here. You all knew Carl Sagan pretty well. I just wanted to ask what you think he would be doing personally if he were still with us.
Anne.
He would be at the Carl Sagan Institute, although it would have another name. And he would be working with Lisa and loving her as I do, and being really inspired by her commitment. He would be searching for life elsewhere. That was the question that was the second dearest to his heart. The dearest was whether or not we are going to get our act together as a species and protect the life on this world.
Thank you very much. Thanks for the question. Over on my right.
Hi, thank you for giving this presentation. And I was wondering if anybody thought it was possible for life to evolve in maybe the atmosphere of a gaseous planet instead of this solid rocky.
Oh, Steve, go for that one. going to give it to Steve. Life in a gaseous atmosphere.
Sure, I think it's possible. It might be hard for life to get initiated under those sorts of conditions. I wouldn't rule it out. But what we have found is that life is incredibly tenacious at evolving into ecological niches. So I think it's a definite possibility. It's going to be very different from the kinds of life forms that we're most familiar with, but I wouldn't rule it out by any means.
Frank, you wanted to add something.
I want to add something that actually Carl Sagan suggested.
Yes, right.
Exactly what you proposed.
Yep.
And it was the first paper proposing extraterrestrial intelligent life ever published in the eminent journal, the Astrophysical Journal.
Carl Sagan and Ed Salpeter.
And Ed Salpeter.
And Salpeter.
I was going to say the same thing. Hunters, floaters, and sinkers.
Right.
3 different life forms that had a plausible evolutionary history and a plausible ecological relationship to each other.
Yep. We'll have to go looking for them. Thank you. Yes?
So first of all, thank you all for your tremendous contribution to exploring the secrets of the universe and igniting the sparks of passion in the young minds like mine. And my question is, if we find aliens and we establish a good contact with them, how do you think the humankind would explain the fact that we have made so many movies where we fight them?
Okay, I'm going to give this to Anne.
Yeah. You know, it's to look at those movies is to see human projection writ large, our fears, the idea that they're so often reptilian or insect-like. And I say beautiful until proven ugly, that when we do make contact with another life form, I think we will be as astonished at this form that nature has taken elsewhere as we are when we look at a snail or an elephant or a bird or a lobster. Just the ever-branching ramifications of life and nature are so stunning that it's tragic and pitiful that when we imagine the evolution of life elsewhere, all we can see is the ugliest part of ourselves.
I think
Lisa,
just
quickly,
very
yes.
quick add-on. I think first they're going to follow a laughing what we thought they would look like if they identify that this is what we think aliens would look like. So I think it's not going to be any problem that they see, oh, I think it's more a comedy show.
Thank you.
Thank you. Okay, 15 seconds on my right.
Hi, first, thank you for blessing us with your presence and inspiring talks. So my question is, do you ever think about what we're going to do after we find extraterrestrial intelligent life? And do you think people will be disappointed if we are truly alone?
I'm going to ask Frank to answer that question from the truly alone point of view. Will we all be disappointed? What will happen? And
from the what point of view?
From the truly alone.
So
Truly
there were
alone.
2 questions asked. I'd like to take the second part of that question, because I think the first part was partially answered already. Will we as a species be truly disappointed if in fact we find out that we are alone?
Only the science fiction fans will be truly disappointed. I don't think there will be a national wave of despair.
Great, thank you. You have... Go for it, yeah.
Let me ask you a question. How could we ever find out that we're truly alone?
That's
We'd
the
have to
problem.
survey
That's right.
the entire
Yeah.
cosmos.
And if we could, what a sense of responsibility we would feel.
That's right.
We're it.
Yeah. I think the question to ponder is, how would we actually know that?
Yeah.
It's something that may in fact, is in fact unanswerable, I would argue. Okay, you have the last question.
Yeah,
Speed,
go ahead.
question, and answer.
Of an analytical mind, too, it's hard for me listening to so much going on, you intelligent people up there, to try and keep it down to 2 quick questions. Good.
One question.
One.
You get 1 question.
Hunter,
Okay.
all right, then to Mr. Stevens, Professor Stevens, the Tropic of Cancer on your favorite planet, if space has got no air right, and void. How's the storm on the Tropic of Cancer, they figure at 400 miles an hour of storm?
I don't understand the question.
All right. I also do a lot of, anytime I can get into any NOVA products, any NOVA programs on TV or any of that quality stuff, they had also Jupiter.
Yes.
So I addressed that to Professor Dr. Stevens there, since that's his favorite planet. If there's no oxygen and nothing out in space, they estimate the storm at the Tropic of Cancer on Jupiter to be a vortex.
I think you're talking about the Great Red Spot, which is an enormous storm.
Right.
And the storm is not happening out in space, it's happening in the gases that constitute the atmosphere of Jupiter.
Okay.
Right, that's what's going on. Good, thank you very much. Okay, excellent. It's very hard to close tonight because this has been such a wonderful experience of these questions and answers, but I want to address the final remarks to the students in the audience. I want to go back myself 40 years and to a time when I nearly, despite my passion for astronomy, decided not to be an astronomer because the job market was so terrible, and I wanted to do something safe like become a medical doctor. Probably wouldn't have been a very good medical doctor, but I was turned back to astronomy, having been inspired by Carl Sagan as a kid. I was turned back to astronomy by a talk that Frank Drake gave in New York City about the Arecibo radio telescope, and I realized that where my heart was in this field, and even though it might be difficult to earn a living, it's really what I wanted to pursue in college. And so for all of you who have any doubts at all, but are inspired by discovery, whether it's at the farthest edge of the cosmos or the tiniest part of the inner working mechanism of a cell, just pursue what's in your heart and work as hard as you can to do that. And you will someday be in a position like these remarkable people of having discovered something that is truly profound and long-lasting about the cosmos that we live in. So thank you all tonight for your participation, and thanks to the others.